take them downing, take them downing, take them down. As you look, the whole room explodes. Take them downing, take them downing, take them. As you look, the whole room explodes.
So, hello boys and girls. My name is Itamar Haber. You pronounce it better than most people. I wish I had Ian's accent. Unfortunately, mine is a lot more Israeli, but I'll try to match. I came to talk about Redis and some introduction to you guys who either know Redis or don't. How many of you use Redis? Show of hands. Good. How many of you don't use any NoSQL? Just you. All right, and the rest, or I guess everybody here uses some sort of a database, probably SQL as well. So let's start off with the formalities, a little bit about myself and the company. My name is Itamar. I'm the Chief Developer Advocate at Redis Labs. All right, this is really annoying. Let's try this. One, yeah. All right, cool. So I'm the Chief Developer's Advocate at Redis Labs. That's like a catch-all title. I basically do talking. I write blogs, I try to respond to users and do as much noise as I can. Some of my peers are here. Redis Cloud is what we do. Redis Labs is the provider of a Redis Cloud. It's a cloud-based service, and we provide Redis, a managed hosted Redis. And I invite you all, after my talk and after the talks are over, to come by our booth outside and get your free t-shirt and sticker. I guess I'll have to come back here occasionally. So what is Redis? I saw a lot of hands raised, but I'll try to keep it short now. Redis is a NoSQL database. It's a key value store. And before trying to bend your minds and blow them probably with what's a key value data store is actually, one of the things that Redis does, or is probably well known for, is that it's an in-memory database. That means that unlike other databases, it doesn't use disk, or rather it can use the disk, but only to persist your data. All data in the database is kept at all times in RAM, and this is the secret for its amazing performance. It's really, really, really fast. It's unlike anything you've seen before, and this is probably the #1 reason why people are so anxious to use it. If you need scale, if you need performance, if you need really, really high volumes of traffic, you should look into using Redis. So what is a key value store? Generally, if you're coming from SQL, and this is basically this little create table statement is the justification for the blasting title that I put on this talk, Introduction to the SQL Practitioner. It's just this example. A key value store is like a big table that has only 2 columns. One column is the key, it's the primary key. You reference your data in the database with that key. The other column is the value key. And if I was to use, let's say, MySQL to create a key value store, and some people did that actually, if you're familiar with a small internet site called Reddit, this is something that they did inside a SQL database. You can create something like a key value store just by trying this little create statement. But Redis is much more than that because it has 6 data types, and with data types I mean the value of each key can belong to one of these 6 data types. It has 160 commands overall. I counted them yesterday. And it's blazing fast. I don't know if I've mentioned that before. It was created about 5 years ago, if I'm not mistaken, by guy, an Italian guy, who is a self-proclaimed rude Italian guy called Antares, or also known as Salvatore Sanfilippo. It's an open source project, meaning you can just go on and just go to GitHub, download the source, compile it on your local desktop, machine server, what have you, and start using it. You don't owe anyone anything. You can actually start tweaking it, modifying it, and you'll get help with that. I really urge you to go to Redis's website, which is called redis.io. Everything you need to know, or most of what you need to know, is already there. It's a very cute website, and you should try it out. So why Redis? Why Redis anyway? So besides the fact that I don't really remember, but it's really, really fast, but it's also very, very simple. It's deceptively simple. It has a lot of commands, but all the commands are very, very, very basic, and it doesn't take a lot to understand them, and how to use them is really trivial. The commands are very, very short. So it's simple. But on the other hand, with simplicity comes flexibility. You can actually use it to build anything you want. And this is what people do. And this is probably the major deterrent of Redis. It's so simple, and we're so used to having everything ready and made out for us that we don't understand that with Redis, we actually have to build it. But once we build it according to our own specs. We do with it what we want to do with it. Performance, so it's really, really fast. That means that you can easily serve thousands, tens of thousands, and even hundreds of thousands of requests per second from a single server, which is really, really cool. My laptop, which isn't the newest laptop in the market, in a recent benchmark I just ran on it, inside a VM, pushed above 200,000 operations per second, which is, I think, is impressive. It's also very, very lightweight, unlike probably other systems that we're familiar with. When you boot up Redis, it only takes about slightly less than 2 megabytes of memory when it's empty. So it's really a lean and fast machine. And besides all that, it's also being used out there in the industry. Some big names like Twitter, Pinterest, Snapchat, HipChat, Stack Overflow, and one of the upcoming successes is Tiowaki, which my successor, the next speaker here, will present as well. All these guys are using Redis, and they're quite happy with it. So I think, I think that one of the neatest things about Redis is the fact that it really makes you think. It's simple. It doesn't come with a lot of built-in functionality in terms of ready to use, but it makes you think about what you're trying to do and how you're going to achieve it. Once you go down and start thinking about the problems that you're facing, you're going to end up with arguably a better solution. So you need to think about the data that you're keeping in there. You're not just throwing data blindly into the database and then hoping that one day you'll be able to do something with it. You need to think about how you're going to access the data. You need to think about the performance and the efficiency of your operations, the network. You really need to think. And as much as it's painful to think, it pays off eventually. Thinking beforehand usually pays off later. You can think of Redis, and this is how some people define it, as a database construction kit. Not just as a database, you can actually build databases with it. You build your database with this amazing tool that's called Redis. Lastly, a word of advice or caution. I'm sure most of you are familiar with some variation of Maslow's rule or the golden hammer. Basically, I'm a firm believer that for every job, there's the right tool. So just like SQL has been around for so long, and eventually NoSQL came and showed us that there are other ways to do stuff. There is no magic bullet. There is no silver arrow. You need to pick the right tool for the right job, so don't just opt into SQL just because this is what you know. And on the other hand, don't jump into Redis once you fall in love with it for any task. think about what you're trying to do and pick the right tool for the job. Now, let's look into the juicier stuff. I tried organizing my presentation in the form of some use cases or use patterns that I hope will grab your imagination and convince you that you can use Redis and want to use Redis. Once you start using it, it's like heroin, you can't really stop. But here's a simple use pattern. So I mentioned that Redis is really, really fast, I think. One of the things you want to do with a fast machine or a fast system like Redis is use it for caching. So let's assume you have a SQL database that you're using, and SQL databases are at least comparatively slower than Redis. But you need speed, you need performance. I had a discussion the other day with one of our customers, a gaming company that specializes in producing social mobile games. And one of the things that they said, listen, performance for us is everything. Our user has 5 minutes, he has a cigarette break, he goes downstairs, opens the phone, and he wants to play. Every delay in his experience, and he'll just throw away the game and move on to another game. So you really want things to move fast. And how do you make a database move fast? You cache it. So the pattern that I'm displaying here is my arguably lame attempt at actually doing some real programming. I tried using a language called Python or something similar to Python. I'm not sure this will actually run, but I hope it will get the message across. You can cache your database calls into Redis. And the basic logic is, let's look in Redis, let's take the SQL statement and convert it into some sort of a hash sum like MD5. And then let's look into Redis. Now Redis is a key value store, and the basic primitives for getting keys from Redis is using the get command. You get from Redis something called the hash of that SQL. If that hash, if that key exists, then we simply return the results, the data, to the application. But if it doesn't exist, we'll go ahead to the database, execute that SQL, and then hash it into Redis. And another thing that we can do with Redis is not just hash it, Redis also supports the setex command, or offers the setex command, short for set and expire, and Redis can be used as a real cache. It can expire your data after a predetermined time that you set for it. So this is one use for Redis, and actually this is a very popular use for Redis. You see Redis is used as a cache. In fact, often it is mentioned or referred to as memcached on steroids. Memcached, I'm sure, or maybe I shouldn't be sure how many of you know of memcached. Heard of memcached, worked with memcached. All right, quite a few. So Redis actually is a sort of replacement to memcached, but much, much more. So let's look at another, let's review some of the things about Redis. I mentioned Redis has 6 data types. The first and foremost, and maybe the most important data type that Redis offers is called a string. A string is what you expect it to be. It's just a string of characters. Strings are binary safe, like everything in Redis, so you can actually store binary data in them, and Redis wouldn't care. There are all kinds of operations that strings support. So besides just storing strings and doing stuff like getting the string length or getting or appending to a string, getRange is what in other programming languages is called substring, and setRange is replace inside the string. So you can do stuff with string very, very efficiently, very, very quickly. But strings can also be used to store integers, and then you get a neat family of commands like the incr command, which is short for increment, so you can increment integers, or decrement them, or increment them by a specific number or a specific amount. You can also do float mathematics with Redis. You just store floats into strings, and then you can do an incr by float, which means increment the string value, which is a float value actually, by a certain amount. And last but not least, Redis strings can also be used for bit operations. So you can actually do bit operations on strings, stuff like set a single bit inside a string, get a bit, count the bits, and bit operations like and, not, and all that neat Boolean stuff. And you can implement whatever you want with it. So moving onwards, let's look at another pattern of using Redis, and instead of caching database calls, why not just avoid using a database at all? Why not store stuff in Redis? I mentioned that Redis is persistent. You can use it for persistency if you want, but sometimes your data doesn't really have to be persistent, like in this example. One of the things that you can do, for example, is keep transient or ephemeral stuff in it, like session information or shopping carts. So imagine you have some kind of a shopping site that you're trying to build, and you want to have your shopping cart. Now, a shopping cart is very important. It's where the customer puts stuff in, but it needs to be available to all your application servers, so you need some kind of a shared storage. You use Redis because it's fast, in case I didn't mention that. And in order to use the session, you can look at my nifty add to cart function. You pass it the user session identifier, the product identifier, and the quantity. And then you do some kind of logic like storing the new quantity. If it's bigger than 0, you store it inside the cart with the product, or you just remove from the cart if the user zeroed the quantity, you remove that item from the cart. And then just to finalize everything, if you want to get the cart contents, you just use another command called hgetAll. Now, earlier in my previous example, I showed you the get and set commands, which are used to get and set the value of a string. Notice that here I'm using another command, or other commands, which are called hset and hrem and hgetAll. The H is for hash, and that's another data type that Redis offers. Hashes are sort of like a mini Redis, a Redis within a Redis. You can have a key and a value pair, and the value is in fact a hash map. And you can see in my example here how hash maps behave. So if we take, for example, the user entity, we want to keep information about the user, you could do it with just strings and set the user ID to ID, and the user first name to foo, and the user last name to bar. And each one of these is a separate key. But in NoSQL, because it's a NoSQL database, it's a non-relational database, one of the practices that you do, and you'll see it a lot, is you aggregate stuff together, sort of like tables entire row or an object representation. And hash maps are actually a very convenient way to do that. I just use a single key, which I call user:1, and inside that hash map, I do age sets to each of the various values. Each such value is sort of like a key value tuple. So hashes are another nifty data structure that Redis offers us. They support a wide range of commands. Some of them I've shown you, or at least suggested here. You can see that hashes also support incrementation, so you can do operations like counting inside hashes. You can get all the keys inside a hash, all the values inside a hash, some of the values, and so forth. Another pattern that you see a lot in NoSQL databases is denormalization. We're really used to having our data normalized in SQL databases. NoSQL offers no referential integrity, no constraints, so you need to denormalize your data. And that usually means you'll see a lot of data duplication inside your database. If, for example, you're keeping the country for each of your users, you'll see the same country being repeated for each user. So it looks like a huge waste of space just repeating the same value over and over. This is something that we're being taught from the beginning in SQL that you should avoid at all costs. But actually, this is a trade-off. It's a trade-off between memory or storage volume, memory in Redis's case, and complexity. The fact that I'm duplicating everything makes the complexity much, much lower. I can get the stuff without unnecessary operations like going to another table and fetching the rows or the values. Let's look at another pattern. Sometimes we want to keep track of the order of things that happened. For example, if we're talking about a shopping site, maybe we want to show the user the recently viewed items that he looked at, whether he added them to the cart or not. This is very, very easy to do with Redis with the list data type. The list data type is basically a linked list, item linked to the next item, to the next item, and so forth. And with Redis, you get that data type built in for free. You use the lpush to push stuff into the list. On the left end, you can do ltrim, like I did here, to keep the list at a certain size. 0 to 9 means keep the list items from 0 to 9 and an overall of 10 items. And then to get the entire list, I can do an L range from 0 to -1. -1 marks the last element of the list. -2 is the one before that, and so forth. Talking about key names, by the way, some key points about Redis's key names. So key names are limited to only 512 megabytes. I hope you can do with that, as are the values. So a key value pair in Redis can be at most 1 gigabyte overall. To conserve your RAM and CPU, try to keep your key names short, because every key name, unlike column names in SQL where you define the column name once and then just refer to it, in Redis, once you set a key, the key's name is also a part of the key, of the data. It's stored there. So you don't want to use arbitrarily longish key names. You want to keep them short. On the other hand, don't make them too short, because eventually your key names are your schema. There's nothing else but the key names to describe your data. So make sure that they're not too short. Don't be too stringent. You need to be able to identify the data by the key name. As a matter of convention, by the way, and you'll see it in my presentation, we use the colon to separate between elements inside the key names. It's just a convention. You can use whatever you want, underscore, slashes, what have you, but the convention is to use colons. Let's look at another pattern, which is coincidentally just here because we talked about lists. Lists also lend themselves very, very easily to implementing a queue. So, and let's switch our example. We were talking up until now about shopping carts and e-commerce sites. Let's talk about some sort of a social-like site. So imagine your user uploads a photo to the social site. He wants to share it, and several things need to happen in the background before the picture is actually shared. It has to be resized to a thumbnail, maybe moved to some kind of storage. This you don't want to happen online while the user is waiting. You want to implement some kind of asynchronous queue that a worker can go to and fetch the work, do the work while the user is continuing his experience on your site. So with lists, you can very easily implement a queue, and I'm showing you here how to implement the enqueue and dequeue operations. So basically, to enqueue something, you just push something to the left side of the list, and to get something from the queue, you just pop it from the right end. By the way, I won't go too deeply into this, but Redis also has another version of pop, which is called a blocking pop, in which this code, if I had used it, would wait until it will, if the queue is empty, the worker will wait until there's something in the queue or a timer will it be expired. Talking about databases, there's also there's always this question, and specifically if we're talking about the queue, what happens if two workers try to pop the same queue at the same time? Who would win? Would both of them be able to pop? Is there a possibility of a deadlock? Is Redis ACID? So yes, Redis is mostly ACID. The fact that Redis is ACID is derived from the fact that Redis is mostly single-threaded. That means there's a single thread serving all of those hundreds of thousands of requests per second. And this keeps everything very, very simple. There's no chance of collisions or deadlocks and nasty stuff like that that you see in other concurrency models. So every operation in Redis is both atomic, consistent, and isolated. Additionally, Redis also supports durability, but it's a trade-off, like everything in life. Durability being the fact that you can write stuff to disk from RAM. And Redis has a configurable way to do that, and it's a trade-off between performance and safety. If you want good performance, you'll probably put less of an emphasis on your durability and the persistence of data. But if safety is important and data can't be lost, you can write every operation to disk if you want. Of course, chaining your disk to the RAM will make everything much, much slower. You can also do sorts of transactions in Redis. There's a set of commands called the watch multi-exec, which is like a transaction in the SQL world. It's like a transaction in the sense that the only thing that it doesn't support are rollbacks. And you can pretty much achieve the same effect with server-side Lua scripting. Let's talk a little about searching in your database. So we have a lot of data in the database right now, and we want to find it. We're not sure what we're looking for, and we want to scan the database. This is something that, of course, Redis allows. You have a bunch of commands called scan commands, which are basically like a cursor. You provide a pattern for a key name. You let Redis run. It returns with a set of results. You do something with the data, perhaps print these users, then go and fetch another batch, print them again, and so on until your cursor runs through your stack. Indexing. So another very important part of data operations. You can actually index stuff in Redis. However, indexes are not built in. You have to build them yourselves. How do you build indexes? You use another data type. It's called the set data type. The set data type basically allows you to keep unique members inside a single key, and you can just add members to the key, fetch members from the key, delete members from the key, and do all sorts of nifty stuff like joining sets, intersecting sets, unioning sets, and all sorts of stuff. I need to pick up the pace because I didn't plan accordingly, but we're near the end. Another nifty little data structure that Redis has, like sets, is called the sorted set or the Z set. The Z set is just like a set in the sense that it has members. Every member is unique in it. But on top of that, each member can have a score, and you can actually sort stuff by the score. So you can use Z sets when you want to sort data. Redis, in its latest version, also introduced lexicographical ranging. So if your members are alphanumeric values, you can do alphanumeric ranges. So here's a little example of how you sort things with a set. Let's skip that. There's also a sort command, by the way. It's been there forever. It's probably the most complex command in Redis, but it's there. I invite you to take a look at it and learn it. And I want to wrap up with my favorite thing. That's counting. I love to count, and probably this is why I love Redis so much. Redis is one of the most popular use cases of Redis is counting stuff. You just count and count stuff. What can you count with it? Everything. You can count statistics. For statistics, you can count stuff for real-time analysis. You can count stuff for dashboards. You can count stuff for throttling requests and APIs. You saw that there are a lot of ways to count. You saw all the incr commands that Redis supports. Here's a little example of how to count the number of times a user or the number of days a user has logged into your system. And I'll finish my talk with one of Redis's newest addition, which is called the HyperLog Log. The HyperLog Log is a very nice data structure that allows you to count unique items effectively using a constant memory footprint, only 12 kilobytes to count billions and billions of stuff. Think about it. If you want, there's a blog on our site that tells more about that. There's more, but I don't have time, so you'll have to catch up by yourselves. What's next? You can go to redis.io. you can come to our site and get a free 25 megabyte Redis instance on the cloud to play with. If you need help, there are lots of documents. There's a mailing group that's very, very active. There's an IRC chat room. And of course, you can always email me. I'll do my best to answer you. That's all. Thank you.
And obviously they can visit you at your booth outside.
Yeah. Any questions outside?
I have a few, but short ones. How many connections does it support in parallel?
There's no limit. There's no limit to the number of connections.
Okay. Does it have a REST API?
Not built in, but either you build it or you can download one of the ready ones. There's one called Lark, I think. It's written in Python, in PHP, I think. Everything's open source. It's very easy to implement in REST API.
Okay, and last one, batch load. Does it have a batch load?
What?
Batch loading. Like one
Batch?
time. Batch loading, one file loaded in one time. Instead of just
Batch?
batch loading, yeah.
Batching stuff?
No, just loading one time. You get one file, you want to load it as one batch. Into the
All right. Bulk loading?
Yeah, bulk loading,
Yeah,
sorry.
that's also, there are a couple of ways to do that. Redis supports pipelining, so you can push stuff down its throat very, very efficiently, or you can even skip the clients and just talk native protocol. There's actually an article about that in Redis IO that tells you how to do efficient bulk loading.
Thanks.
One more? Nope. All right, thanks a lot.
My pleasure.